Hello everyone, welcome to my your programming club. Today we will be solving the questions of today's weekly Leetcode contest. So this was the today's weekly Leetcode contest, weekly contest 356. Now let's solve the problems of this contest. So the first problem of the contest is number of employees who met the target. So the problem statement is like this: there are given n employees in a company numbered from 0 to n minus 1. So the array that in which the employees are given, the data of the employees are given is of the 0 indexed array. So each employee I has worked for hours at the ith index. So let's say the first employee have worked hours at the first index, which is 1, and let's say third employee have work 3 hours, so on. So the company requires each employee to work at least target hours. So each employee is required to at least work target hours. So you are given a 0 indexed array representing the hours each employee works, and you are required to return the number denoting the number of employees who worked at least target hours. So what the problem statement is saying, for example, let's consider this input. So this was the input. We were asked how many these are the hours employees work. And this is for the 0th employee, this is the first, second, third, fourth, and so on. We have to tell the number of employees who worked at least target hours. What are target hours? Here, these are the target hours. So this is a very simple problem. We'll just iterate over the input array hours and count the employees whose hours are greater than the target hours, and if the hours of a particular employee happens to be greater than the target hours, then we will increase the count, and at last we will return the count. So this finishes the first problem of the contest. Now let's move to the second problem of the contest, and the problem's name is count the complete subarrays in an array. So the problem statement is like this: you are given an array nums consisting of positive integers. We call such a subarray and a complete array if the following condition is satisfied. The number of the distinct elements in the subarray is equal to the number of distinct elements in the whole array. So for example, let's consider this input. So this was the sample input given. So what are the total number of distinct elements in the whole array? There are 1, 3 and 2. So 3 distinct elements in the whole array, full array, or say whole array. So these are the number of distinct elements in the array, and let's consider this subarray. Let me quickly change the color. Let's consider this subarray 3, 1, 2. Those of you who do not know what a subarray is, subarray is a contiguous part of array. What I mean by contiguous, that you cannot have breaks in between. For example, it cannot be like you take this 3 and then you take this 2. There are no elements in the middle are not considered, so it is not contiguous, so it's not a subarray. I hope you are able to understand what a subarray is. So the subarray currently considered is this. So the number of unique elements in this subarray is 3. So this is the subarray, these are the subarrays, this type of the subarrays are the subarrays we are considering. So this type of subarrays are called complete subarrays. Complete subarrays. I hope till now it's clear to you. And what we are required to return is, also it's being said that subarray needs to be non-empty, so you cannot take 0 elements from the array and call it a subarray. And what we have to return is, return the number of complete subarrays. So among all the subarrays of input array, you have to return number of complete subarrays. So this you have to return number of complete subarrays among all the subarrays of the input array. So how will we doing it? First of all, for checking if a subarray is complete or not, you have to check the number of distinct elements in the whole array. Now a whole array is also a subarray of itself. I am telling you so that you keep it in mind while calculating the number of subarrays which are complete. So for that, what we'll do is, we'll simply add the elements of the array in a set, and count the set size will be the size of this set will be the number of unique elements in the whole array. I hope the use of this set is clear to you. And now, since we are only interested in the subarrays whose whose unique elements are equal to the unique elements in the whole array. So what we'll do is, and let's check the constants also. The constants are length of the given array is of the order 10 raised to power 3, and the elements values are of the order 2 into 10 raised to power 3. So we can easily apply a brute force way. Actually, this is not a brute force way. A brute force way would be to generate all the subarrays and then iterate over each of them to count unique elements in them. and it will take you order of n cube time complexity, and n here is of the order 10 raised to power 3, and its cube will be 10 raised to power 9, which is greater than 10 raised to power 8 operations. Let me quickly change the color. 10 raised to power 8 operations allowed in 1 second. Those of you who do not know how the time complexity of accepted solution varies according to input size, I will provide a link of article describing this. Then you will be understand what I am talking about here. Right now I can tell is you are only allowed to do 10 raised to power 8 operations in 1 second. So your time complexity in a order wise fashion, it should be lesser than the 10 raised to power 8 in order to be your solution to be accepted. So here it's you will generate a subarray and then iterate over its elements, and it will take n cube time. So it will give you clearly. What you can do is you can optimize over this brute force. How will you be optimizing it? What we are doing is we are first generating the subarrays, and as we are generating the subarrays, what we are doing is we are adding the elements that we are encountering. For example, let's consider this is the left pointer. We are taking two pointers, one is left and another one is right. This is the left pointer and this is the right one. Initially both are pointing to the start of the array, and then what you are doing is you are increasing the right pointer till it reaches the end, starting from the current position of the left pointer. So as the right pointer moves to the next elements, what you are doing is you are adding them in a set. So set will only contain unique elements. So for each possible value of left, you are iterating over the array from left to right till the end of the array, and you are adding those elements to the set. And for a particular subarray, let's say left is here and right is here, and in between all the elements are added in the set. Now set is representing the subarray starting from the left index and ending at the right index. So and the size of the set will be unique elements in this subarray. Which subarray? The subarray between left and right indices, both of them included. And how will be counting the unique elements? What we'll do is let's say size here in this example, let's say left was here and right was here. Left was at 3 and right was at 2, and the set was containing these elements 3, 1, 2. Now the size of the set is 3, and the total number of unique elements in the whole array were 3. So size of the set size divided by unique elements can be added to our final answer. So it will be the contribution of this subarray which is in between left and right indices. So what we are doing is we are adding the contribution of subarray between left and right indices, both of them included, to our final result, or say answer, and at last we will be returning our result. So I hope you are able to understand. And the time complexity for this solution, order of 10 raised to power 3 was the input size, so it will be 10 raised to power 6, which is lesser than 10 raised to power 8 operations, so it will be accepted. You will get IAC for this solution. I hope it's clear to you. Now let's move to the third problem of the contest, and the problem name is shortest string that contains 3 strings. So what the problem statement is saying, given 3 strings A, B and C, your task is to find a string that has minimum length and contains all the strings as substring. So let's say we are considering this example. So let's consider this example. What we are required, return the substring, return a string which is of shortest length possible and lexicographically smallest among all the shortest length answers or strings, such that A, B and C are substrings of this string. So this string you have to return. I will be returning this string. So to return such a string, what we will do is, since the constraints of the problems are not that much bigger, so they are not of such a concern to us, what we'll do is, as long as we are not writing time complexity greater than n cube would be 10 raised to power 6, since input size is 10 raised to power 2. So till here it will be fine. So as you can see, because for checking what is the shortest string, you have to iterate over the strings so that you should be able to greedily pick such a whole string that is containing all these strings. What you will do is, for example, let's consider this example. let me quickly copy it again. Let's consider this example. For each of the strings, you will be having three options. Either to let's say for the string ABC, you are having three options: ABC, BCA, and AAA. To include all these strings, it will not make sense that you are checking with the same string or appending the same string to itself. It will not make sense. And for the other two, what you will check is, let's say you picked ABC and BCA. What you will do is, you will check what is the longest prefix of the second string, that is a suffix of this string. What I mean to say is, what is the longest parts from the starting side of the second string. Let's say this is the first string and this is the second string under consideration. What is the longest part of the second string starting from starting position, which is the ending part or say suffix of the first string. So this BC is common between these two strings, and this is the largest suffix, which is the prefix of this string, second string. So this much part you can say while appending it. So in order to make such a string that is containing both of them as a substring, you can save this much part, and you have to just add A, B, C. This was already there, BC was already there, and to make the second string you will just add A. So this is how you will greedily select such portions from the strings under consideration. Let's say this was the current string and this was the string under consideration, and it was not previously included in the current string, so we'll check for that. We will skip all the let's say we have checked for these two, and this again will be having three options: BCA, which does not make sense, checking the same string again or adding the same string to the string itself, and the rest two options will be ABC, and the third option will be AAA. So see, this ABC we have already checked and included in our current string. Now this will be our current string, and we were having these two options. Since this does not make sense, it's already included here, so we will not be checking for it. So what we'll do is, and this is already included, this is not included, so we'll check for it. What we'll check for, what is the largest prefix in this particular string under consideration, which is also a suffix of current string. So what is the largest one? Only A is the largest one, as you can see. So what you will do is, you will simply skip this and add rest to A's. So this will be the final string, which is the shortest string, and you will be finding many such shortest strings, and you have to return lexicographically smallest such string. So among all the strings of this length, this is the shortest length, you will find the lexicographically smallest string. So what will be the lexicographically smallest string? This will be the lexicographically smallest string among all the strings possible. Or and now you may also ask, what happens if there is no prefix which is a suffix of the current string? There is what happens if there is no prefix in current string under consideration, which is a suffix of current string. So in that case, what we'll do is we'll simply add that string under consideration to our current string at the end. It will be current string plus current string under consideration. This will be our new current string. Since we are not able to save some characters while appending, so we'll anyways append this both too, and they will be forming our answer. And we'll among the answers of the same lelenth, we will be returning the lexicographically smallest. So I hope it's clear to you. So here, as you can see, the length is 6. Here the length is also 6. But this one is the lexicographically smaller than this one. So we have written the lexicographically smaller one. And how will be implementing this solution? What we'll do is, and you may ask how we will be, just a second. You may ask how will be checking for the strings which are already added in the current string. Let's say this is the current string and you have added the string at the 0th index and the first index, only this one is remaining, and you have to check whether these two strings are added or not. So what you can do is integer variable is of 32 bit, so you can use these 32 bits to store the indices already added in the current string. So this 32 bits integer will form a mask. This concept is called bitmasking, storing occurrences of numbers or say indices or anything in a 32-bit integer with the help of bit manipulation. So those of you who are new to what a bitmask is, I will be providing a link for it, article describing what bitmask is, so you can check it out there. So what we have done is, we are taking initially the string to be formed is empty and no strings are currently added to it. Starting from we are adding these strings in a vector and we are iterating over this vector from the 0th index till the last index, which is the 3rd index, which is the 2nd index. As soon as the index reaches to the end, we will return the current string. So what we have done is, for each iteration we have considered a string which is initially empty, and this string will be the lexicographically smallest string, which will have all the 3 strings as their substrings, as its substrings. So what we have done is, for we have one by one we are considering all the three substrings and calling it the string under consideration. And if the string under consideration is already present in the this current string, which we will check by ending the index value left shifted by one left shifted by index value and ending with it the mask, and if the value is not 0, it will represent that the current string is already present, the current string under consideration is already present in the current string. So we will continue it, we will skip this part, and if the current string under consideration is not present in the this string, current string, what we'll do is, and it might be a case that there might be a case, for example, the input will be like this. Now these are the three strings given to you. This is A, B and C. Till now you have considered these two indices, let's say 1 and 2, 1 and 0, and formed this string. Now you are considering this index string at this index, which is A. Now though you have not considered this index previously, it will not be stored in the bit marks that we are forming. Only the 0th bit and the first bit will be set in the bit mask. These two bit will be set, the second bit will be unset. So this will be our bit mask, though this bit is not set, but this string is present here. So in that condition, what we'll do is, we will just add that index to the mask, and we'll simply increase our index by 1, and that will be the shortest string that would be possible. And how we'll be checking if the newly formed string, this newly formed string is of greater use, or say can replace the current shortest string. So how will you be checking it? If let's say the current shortest string is empty, in that case you will simply exchange it with the newly formed string. What is the newly formed string? That this recursive call will be returning us. This recursive call, minimum string recursive call, will be returning us. So I hope it is the case when though the index is not considered, but the string is still present in the current string. So I hope it's clear to you. And if the current shortest length string is of greater length than the newly formed shortest length string, then we'll replace the current shortest length string with the newly formed shortest length string. What is the newly formed shortest length string? The string which will be returned by the recursive call. What will be the recursive call? This will be the recursive call, increasing the index and adding that particular index to the mask. And if they are of the same length, then we will return the lexicographically smaller string. So I hope it's clear to you. And if that's not the case, if neither this position was previously considered and nor this string is present as a substring in the current string, which string is not present in the current string? The string under consideration. Then this case will be executed. It's pretty much similar to this case. So as soon as you find the shortest one, you will break from the condition. Why we are, you may ask why we are breaking from the loop here, because we want to maximize the length of the prefix in a string, which is also a suffix in the current string. So in order to do so, we are breaking as soon as we find the string that ends with that is a whose prefix is of largest length and which is also a suffix in the current string, then we will break the loop and we will return current shortest string after updating it if this condition satisfies. And yeah, that will be our answer. I hope you are able to understand it. If you are still not able to understand it, I have included all the logic and the thinking part in these comments. You can check it out, and if it's still not clear, you can ask your doubt in the comment section. Now let's move to the fourth and the last problem of the contest. And the problem name is counting stepping numbers in a range. So you are given two integers representing the range, low and high, and these numbers are given as strings. You have to find the count of stepping numbers in the range inclusive. So low and high, both of them are to be included, and what a stepping number is, it's further defined as an integer such that all of its adjacent digits have absolute difference of exactly 1. So for example, let's consider this number 987. So all of the adjacent digits of this number, let's say these are the adjacent digits, their absolute difference is 1 and 1. So this is a stepping number. So we have to count such numbers among between this range, both low and high to be included. And since it is said that the answer can be a large number, you have to return 10 raised to power 9 plus 7 modulo to the answer. And a note is given that a stepping number should not have leading zeros. So you cannot take such a number. Let's say this is the number. This number is not valid since it is containing leading zeros. I hope it's clear to you. Now the constants are the main issue here. Since they are very high, 10 raised to power 100 is very much greater than 10 raised to power 8 operations. Let me quickly change the color. Allowed in 1 second. A brute force way to solve this problem would be you iterate over the range from low to high, and for all the numbers between this range, you check if they are stepping number. Check if stepping number, and if yes, then increase the count of the count is our answer, and if no, then count remains the same. So it will not be possible to show in 10 operations lesser than 10 raised to power 8 operations, and it will be very much difficult. So let's check the other constant so that we can get a hint how we'll be approaching this problem. Now the length of the both of the strings is given of order 100. Also, if you do not consider these numbers as strings, then also 10 raised to power 100 is having 100 digits. Hundred digits are pretty much manageable if we somehow make a solution around these, and it will low and high always consist of only digits. So digits will be from 0 to 9. This will be 10 digits. Only 10 digits will be there. So for, let's say, we are forming our number. Let's say our current maximum range or the high is 5 2 6 3 4. So let's say this is the number we are trying to form, and if we consider all the 5 digits to a number of 5 digit which is lesser than or equal to this number, then how many options we will be having? If we are making the number from left to right, let's say, then if say we are considering a number lesser than 5 here at this place, let me quickly change the color. At this place, if we are considering a number less than 5, let's say we consider 4, these rest of the digits are not bounded to any value. You are having 0 to 9 options here, yani, what is it, 10 options here, 10 options here, 10 options here, and 10 options here. What are the 10 options? 0 to 9 digits. You can place any of them as per your choice. But if you let's say place a number which is equal to this position, let's say we place a digit which is equal to the digit at this position in the our maximum range, which is high. Let's say we place 5 here, then you are bounded, that you cannot place for this. Let's say if you are considering for this, you have already placed 5 here, then in the previous conditions we were not bounded. Here you are bounded, that you have to place a number which is either lower than this number or equal to this number. You cannot place 3 here, it will exceed your high or the upper limit of the range that you are considering. So you are here bounded to place lesser than or equal to 2. So you are not having here 10 options of 0 to 9. You are only having here options from 0 to 2 only. So if, let's say, and accordingly these places will be decided based upon what you select here. If I, let's say, if I select a lesser value here, let's say I selected a value lesser than 2, let's say I selected 1, then again you will be having here 10 choices in each of these remaining, and these will not be bounded. What is bounded? In terms of choices of digits, in terms of choices of digits. I hope it's clear to you. Then what we'll do is, since it's being said that for now let's ignore this condition. Which condition? That the leading zeros are not allowed. Let's say these all places, let me quickly draw again, and let me take a new slide on itself. Let's say these were the places 1 2 3 4 and 5, and what was the number? 5 2 6 3 4. 5 2 6 3 4 was the number. So let's say 0 is these numbers are 0. So if these numbers are 0, then also these two places Let me quickly change the color. These two places will not be bounded, since these are already lesser than this part. So these two will not be bounded in terms of their choices. You will be having 10 choices each in these positions while forming a 5-digit number. So this is one case. In case these are not zeros, in case these are not zeros and these are some numbers, let's say this was 3. Now according to the problem constraint, the adjacent digits difference can only be at max, absolute difference can be at max 1. So either you can add 3 plus 1 is equal to 4 to it, or you can add 3 minus 1 is equal to 2 here. This position will only be having 2 choices. And how the choices of this position will be decided? It will be decided according to the choices made previous to this position. Let's consider this position as, let's say, index, current index. Then the choices of the current index choices, what are the choices in terms of digits? Then the choices here will depend upon the previous index choices, previous index choice. Since only the absolute difference of 1 is allowed in adjacent digits. So I hope till now it's clear to you. So what were the two conditions? Either the previous digits that you have included are 0, this previous were 0, previous 0, and other one was the absolute difference is of 1 with the previous index choice. Then in these two conditions, you will be adding 1 to your answer, since it will form a number which is a stepping number. So the number of stepping numbers formed will increase. And now you may ask, but here you are considering only the higher end of the range. What about the lower end of the range? How you will be finding between low to high? What I have considered is, I am considering first from 0 to high. Will form a solution from 0 to high. Let's say this is solution 1, and we'll form a solution from 0 to low. This is 0. Let me quickly change the color. This is 0 to high and this is 0 to low. So we have to find this range. So this is the range that we are interested in, including low and high. So what we will do is, let's call this one as solution 2. So for checking with this range, what we'll do is, we'll simply subtract solution 2 from 1. Solution 2 from 1. But this will also remove this low, which is to be included as per the program statement. We will check for it separately. What I mean by check for it separately, the number at low is stepping number or not. How will be checking if the number is stepping number or not at this low position? If the absolute difference at the adjacent digits happens to be not equal to the 1, then it will not be a stepping number. And in case it happens to be a stepping number, we will add 1 to this answer and we will be returning it. This will be our answer. Now the logic will be implemented in the coding part. Now let's quickly move to the coding part so you will be able to understand it in a clearer way. And those of you, and this concept that we have just used here of manipulating the digits of the when two ranges are given and the size of the ranges are pretty much large, and those ranges are consisting of only numbers only, then this concept is called digit DP. Those of you who are new to digit DP, I will be attaching a link to our video, adding a link to our video explaining digit DP. The video is not mine, it's from someone else, but after you will watch that video, I will be highly recommending you to watch that video before starting with the coding part of this program. And once you have watched that video, the coding part which will be clear to you. So let's move to the coding part. So please watch the video before moving to the coding part of this solution. What we have done is we have formed a pretty standard digit DP solution here. What we have done is first we are checking for the range 0 to left. What we are checking? Count of stepping numbers. Then what we are doing is, then we are checking for the count of stepping numbers in the range 0 to, actually this is not 0 to left, it's 0 to low according to the problem. I have considered left as low, and this is 0 to high. So answer will be subtracting number of stepping numbers from 0 to high range, from 0 to low range, and for low we are checking separately. Since the answer is not checking for the low, the number at the low in the range, then we will check for it separately. What will check? If the absolute difference is not 0, in that case we will not include that number on the low of the range, and if we decided to include it, we will simply increase our answer by 1 and return the answer. Now the whole logic lies here. How will we forming our answer? For that, what we'll do is we'll be using dynamic programming for it. Those who are new to dynamic programming, even before going to that video, The prerequisite for that video of digit DP is that you should be having the knowledge what dynamic programming is. And for who are also new to this dynamic programming concepts, dynamic programming, I will be providing a link of an article describing dynamic programming. You can explore dynamic programming, then you can view this video on digit DP. Digit DP is nothing but dynamic programming applied on the digits of the number. So whenever you encounter such a problem where the numbers, a particular range is given, let's say left to right, and the range size is very much greater than 10 raised to power 8, or it's not possible to include it in a solution by some conventional means, and it is said that this range contains only digits are there, and you have to return the count of numbers which follow a particular pattern. The pattern here was stepping number. It can be anything. For example, you may be asked to such that the sum of the digits of the number, let's say this is the number, and sum of its digits should be equal to a target number. You have to return a number of count of such numbers whose sum of digits is equal to the target number between these two ranges, and let's say this range is 10 raised to power 1000. Then by any conventional means or by any method known to us, we will not be able to calculate it. In that case, digit DP will be applied. So please first understand what dynamic programming is. I will provide a link, and then please go to this video that I will be providing a link for, and then come back to the solution of this problem. So what we have essentially done is we are taking 4 variables representing the state of the DP. What will be the let's say 4 dimensions representing DP states. These are the dimensions. First, since the number of digit in a 10 raised to power 100 will be 100, so we have taken only 100 digits. Since it's the zero based indexing, I have taken 101, and the second dimension is for whether you pass the digit equal to the digit in the same index of upper bound. So it was for checking this condition whether it's bounded or not. 0 will indicate not bounded, and 1 will indicate bounded. By bounded we mean based on the previous choice, we are not having 10 choices for each of the remaining positions to be filled, and not bounded means the previous choice was such that we are having 10 choices for each of the remaining positions to be filled, and we are filling the number in left to right fashion. So I hope it's clear to you. The third dimension is for the previous digits. This will keep track of the previous digits. Let's say you decide to fill this position, and the third dimension is for previous position, the digit at the previous position. And the fourth dimension is the number of options you will be having. At max you will be having 0 to let me quickly change the color. At max you will be having 0 to 9, 10 options, for each position. These are the positions in the n digit number. So for each of them you will be having at max 10 options. So we have taken the size of 10 here, and yeah, that's pretty much it. And the I have written in the comments which dimension is for which of the purpose, and we are only interested in two cases. Either the previous digits were 0, or the absolute difference with previous digit is not is 1. In that case, we'll be adding the answer that will be getting from the recursive call of this function. This function count step numbers. I hope you are able to understand what bounded is and what are previous zeros, means all previous positions are filled with zeros or not. And since we are not considering the case in which the number is having leading zeros, then in such case, as soon as we have formed the number of digits equal to number of digits in the upper end of the range, then according to the number is containing the leading zeros or not, we will be returning 0 or 1. And you may ask, what is this num string? This is the num string is nothing but num string is upper end of the range. Range here is considered from 0 to upper end, and this upper end will change depending upon whether you are passing low or high. And that's pretty much it for the solution. If you are having any doubt with this particular solution, I know it's first those of you who are seeing digit DP for the first time, it will be somewhat hard for you to understand it. That's why I have provided the links of dynamic programming and that digit DP video, so that you will be able to understand the solution in a clearer way. Once you have gone through that article and that video, please come back to this solution and try to understand it. And still, if you are having any doubts, please ask them in the comment section. I'll be more than happy to answer it. And that wraps up the solutions for the weekly contest. Thank you for watching. Thank you.